Hey everybody, as you can see, we are taking this remote learning outside today. My kids are fishing. Let's see if you can see that. Yes, they have helmets on. I don't know why, but they do. Whoa, almost got one. All right. So today we are talking the selection sort. So again, I have a video linked in the description down below. So go click that or click the little pop-up that's going to happen, I think, over here. Um, and watch the demo before we get into the algorithm. So I'll check you after you watch that little demo. All right. So in the video, you saw the selection sort is all about picking out whatever the lowest or highest number is. I think in that case it was the lowest number, figuring out exactly where it is and then placing it in the exact right spot, and then going through the list again, picking out the next lowest number, and then putting it in the exact right spot. So you get far less swaps this way, one per full pass in the array versus the bubble sort, in which you could essentially swap on every single iteration, which is what makes it completely and totally inefficient. So here, the logic and how we're going to set things up is we're going to have our integer array, whatever it may be, call it list or whatever we want, and I'm going to keep track of a few indices here. And this may seem a little confusing at first, but just kind of follow through. I is going to be the location of the element that we'd like to put the place into. So if we find the smallest piece, that could potentially be where we're going to set it. That's where we're going to set it. And then I would increase to 1, and then we're going to put the next smallest element there. We're going to go through the entire array, almost the entire array, one less than what we are because we need to figure out if we're in the right spot. So while I is less than the length of the array, minus 1, we're going to come up with a min index. This is us keeping track of where the smallest element is. We're going to set it equal to I to begin with because we're just going to assume we're currently at the smallest piece until we find otherwise. J is going to be a counter that's going to go through the rest of the array to hopefully then find something smaller than what's currently at min index. While j is less than the integer array, we're going to keep going through. We're going to see if we find an element that's smaller than what we're currently storing at min index, and if we are, change min index to be what j is. Now, once we get through this whole process here, we can finally swap the element at I and min index, which will essentially put the smallest element into the place where it belongs. And if we go through that enough times, we'll eventually have a completely sorted array. So that's basically the logic. Again, you can look at this to kind of map yourself over and see how it's all going to go through. But let's go through and code it and see what that kind of looks like. All right, so let's go through this the same way the logic kind of dictates. So let's look at our logic. We want to come up with a control variable I and run a loop, and we're going to keep running this loop while I is less than the length of the integer array minus 1, and we keep increasing I by 1 each time. I actually forgot to put that in here, didn't I? So when we're done with this whole loop, we got to include or increase I. So let's go in there and we'll do that. We'll go for int I equals 0, I less than the this dot int array. Come on, code completion. Let's go. I hate when it stalls. There we go. Int array dot length minus 1 I plus plus. Okay. And in there, we're going to set another variable called min. Okay, that's what our assumed minimum location or location of the smallest integer is in the array. So we're going to go int min index equals I. Okay, and the reason we're going to make it equal to I is because it's going to keep changing as it kind of goes through. And then we'll go through for int j equals I, or we'll go with I plus 1, right? I think that's what the logic says, or min index is the same thing, it really doesn't matter, so I plus 1, right? While j is less than the length of the array, so this dot int array dot length, because we want to go all the way to the end with this one, j plus plus, okay? And what we want to do is go through and see if the value at j happens to be less than the value at min index. So if this dot int array at j happens to be less than this dot int array at min index, what I want to do is not necessarily swap the elements, but just swap what j and min index are. So I want to go min index equals j. Okay, and that's it. That's all I want to do. All right, so we've swapped min index and j. So now min index is holding on to the location of the smallest element in the entire list. And so once we get through this loop here, then we know exactly where the smallest element is. So when we're done with it, we can actually make the swap that we want to make. So I want to swap this dot swap. I want to swap I and min index, because remember I is at 0, or the lowest element in the array, the furthest to the left, the beginning of the array, and we just kind of keep stacking that. And what this does, it only allows me to make one swap per pass through the array on one time, so we're only going through it in this loop. And then we continually just look for where the smallest piece is. And that's essentially it. That's all the selection sort is. Find where the last one is, or the smallest one is, and then move it to the front, find the next smallest, move it to the front, find the next smallest, move it to the front, so on and so forth. And so it makes it a lot more efficient than the bubble sort, because we're constantly not making swaps. We're only making one swap per full pass of the array one time through. We are, though, keeping track of where we are. So let's give it a test and see that it works. So let's come over to our test. And let's call it real quick. We'll go L1 dot selection sort, and then we'll do a system dot out dot print ln of my L1. And we should see that the list is unsorted at first and then sorted at the end. So here we go. There's my unsorted list. Now here's my sorted list. Smallest at the front, largest in the back. If I did, for whatever reason, want to make it so that the largest, or it was in descending order, just flip this, okay? Go look for the max index. You might want to change a few variables around, like max index, so on and so forth, but just switch that around and you've got a selection sort. So it's all about selecting the one piece. All right, so assignment time. All you want to do is log into Google Classroom. Obviously, you're already there because you're watching this video, but now just load up the same code you had yesterday, and all you want to do is finish the selection sort algorithm, where you're going to sort the same names list depending on the instructions in the code. So feel free to try that. Make sure it's a selection sort. If you got any questions, reach out to me, and I'll be here to answer your calls anytime you need. So do that real quick. Shouldn't take you more than 5-10 minutes maybe, and you've got that done for today.